My dear students, welcome back to our channel. In this video, I will be explaining the MBA second semester subject Quantitative Analysis for Business Decisions as prescribed by JNTU and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 1 first important short question is: what is the nature of operations research? Nature of operations research, or operations research, or is the scientific method of solving problems and making better decisions. It uses mathematics, statistics, and logical thinking to find the best possible solution from many alternatives. The nature of OR can be understood as follows. 1. Scientific approach, OR studies problems in a step-by-step way, define the problem, build a model, test it, and apply the solution. 2. Interdisciplinary, it combines knowledge from mathematics, economics, engineering, and management. 3. Decision-oriented, the main focus is to help managers make better choices in business. 4. Quantitative in nature, it uses numbers, data, and formulas rather than guesswork. 5. Optimal solutions, OR does not settle for okay answers, it searches for the best solution. Example, a bus company uses OR to decide the shortest route that saves both fuel and time. Easy tip, OR is equal to optimal results through organized reasoning. Next important short question is: 2. Write a short note on origins of OR. Operations research, OR, started during World War II, 1939 to 1945. The British and American armies faced many problems like how to use radar effectively, protect ships from submarines, and plan air attacks with fewer losses. To solve these, they brought together a team of scientists, mathematicians, and engineers. These experts applied mathematical models, statistics, and logical reasoning to military problems. For example, they studied the best way to arrange convoys of ships so that submarines could not attack easily. Their solutions saved time, money, and lives. After the war, people realized that the same methods could also help in business, industry, transport, health, and education. So, OR moved from the battlefield to the business field. Example, just like the army used OR to decide safe ship routes, today a delivery company like Swiggy or Amazon uses OR to decide the fastest delivery path. Easy tip, OR was born in war, grown in business. Next important short question is: 3. What do you mean by quantitative and qualitative analysis? Quantitative and qualitative analysis. In business decision-making, we often use two types of analysis, quantitative and qualitative. Quantitative analysis means using numbers, data, and mathematical methods to make decisions. It focuses on measurable things like sales, profit, cost, and demand. Example, a shopkeeper checking last month's sales figures to decide how much stock to order. Qualitative analysis means using opinions, feelings, experiences, and non-numerical information to make decisions. It focuses on things that cannot be measured easily, like employee satisfaction, customer preferences, or company culture. Example, a manager asking customers for feedback about why they like or dislike a product. In short, quantitative is equal to numbers, facts, and figures. Qualitative is equal to words, opinions, and experiences. Both are important. A company may use quantitative data to know sales dropped by 20% and qualitative feedback to find out customers didn't like the new packaging. Next important short question is: 4. Define a model in operations research. Model in operations research. In operations research, OR, a model is a simplified representation of a real-life problem. It helps managers understand complex situations and make better decisions. Instead of dealing with the whole real system, a model shows the important parts in an easy-to-study form. Definition: a model is like a map of reality, showing how different factors are connected so we can test solutions before applying them in real life. Types of models in OR. 1. Physical models, real objects in smaller size, example, a mini airport design. 2. Mathematical models, equations and formulas to represent problems, example, profit is equal to revenue cost. 3. Simulation models, computer-based experiments to test outcomes. Example: a bus company uses a mathematical model to decide the best routes and timings to reduce waiting time for passengers. In short, a model in OR is a tool to think, predict, and decide in a scientific way. Next important short question is: 5. List the types of models in OR. Types of models in operations research, OR. In OR, models are tools that represent real-life problems in a simplified way. They help managers test different solutions before applying them in real life. The main types of models are: 1. Physical models, actual miniature versions of real things. Example, a small model of a new school building before construction. 2. Mathematical models use equations, numbers, and symbols to represent problems. Example, profit is equal to revenue cost, used to decide best price of a product. 3. Simulation models, computer-based models that show how a system works over time. Example, simulating traffic flow in a city to reduce jams. 4. Deterministic models, outcomes are certain and predictable. Example, calculating cost if one machine always produces 100 items per hour. 5. Probabilistic, stochastic models, outcomes depend on chance or probability. Example, predicting sales when customer demand is uncertain. These models make decision-making more scientific, logical, and practical. Next Unit 1. Long questions. First important long question is: explain the scope of operations research in detail. Scope of operations research, OR. Operations research, OR, is the scientific method of solving complex problems and improving decision-making. Its scope is very wide because it can be applied in business, industry, government, health, education, and even daily life. The aim is always to use resources wisely and make the best possible decision. 1. Production and manufacturing. OR helps in deciding how to use machines, raw materials, and workers efficiently. Example, a factory uses OR to decide how many shirts and trousers to produce to maximize profit with limited cloth and labor. 2. Marketing and sales. Companies use OR to study customer demand, fix prices, and decide advertising budgets. Example, a company decides whether to spend more on TV ads or social media ads using OR models. 3. Finance and investment. OR is used for budgeting, investment planning, and minimizing risks. Example, a bank uses OR to decide how much money to invest in loans, shares, or bonds for maximum return. 4. Human resource management. OR helps in manpower planning, job scheduling, and training programs. Example, a hospital uses OR to decide the duty timings of doctors and nurses to avoid overwork. 5. Transportation and logistics. OR solves problems related to routes, delivery, and cost reduction. Example, a courier company like Blue Dart uses OR to find the shortest and cheapest path to deliver parcels. 6. Defense and security. Originally developed during World War II, OR is still used for resource allocation, strategy, and planning in defense. Example: deciding the best way to use limited aircrafts during a mission. 7. Education and health. Schools and hospitals use OR for planning resources. Example: OR helps in preparing timetables or allocating hospital beds to patients efficiently. Conclusion: the scope of OR is universal because it deals with better use of time, money, materials, and manpower. Whether it is a business choosing the best product mix, a bank investing funds, or a hospital managing resources, OR acts as a decision-making friend. In short, wherever there is a problem, limited resources, and need for the best solution, OR is useful. Next important long question is: 2. Discuss the applications of OR in different managerial areas with examples. Applications of operations research, OR, in different managerial areas. Operations research, OR, is like a scientific toolkit for managers. It helps them take better decisions by using mathematics, logic, and analysis. Managers in different areas of business use OR to solve problems of cost, time, and resources. 1. Production management. OR helps in production planning, inventory control, and quality management. Example: a company like Maruti Suzuki uses OR to decide how many cars of each model to produce based on demand and available resources. 2. Marketing management. Managers use OR to study market demand, pricing, and advertising. Example: Coca-Cola uses OR to decide whether to spend more on TV advertisements or social media promotions to attract more customers. 3. Financial management. OR helps in investment planning, portfolio selection, capital budgeting, and risk management. Example: a bank uses OR to decide how much money to invest in loans, government securities, or shares to maximize profit with minimum risk. 4. Human resource management. OR is applied in recruitment, training, and scheduling of employees. Example: a hospital uses OR to plan duty rosters of doctors and nurses so that patients get proper care without overloading staff. 5. Supply chain and logistics. OR helps in deciding the best routes, warehouse locations, and distribution systems. Example: Amazon uses OR to select the fastest and cheapest delivery routes for customer orders. 6. Project management. Managers use OR techniques like PERT and CPM to plan and complete projects on time. Example: a construction company uses OR to schedule tasks like foundation, wiring, and painting so that a building is completed within the deadline. 7. Research and development, R&D. OR helps in selecting the best research projects and allocating resources. Example: a pharmaceutical company uses OR to decide which new medicine to develop first based on cost and success chances. Conclusion: applications of OR are found in every managerial area: production, finance, marketing, HR, logistics, and projects. It acts like a decision-making compass, guiding managers to choose the best option among many. In short, OR makes managers more scientific, systematic, and successful in decision-making. Next important long question is: 3. Explain the process for developing an operations research model. V.IMP. Process for developing an operations research or model. Developing an OR model is like solving a puzzle step by step. It involves moving from identifying the problem to giving the best solution. The process is systematic and can be explained in stages. 1. Problem identification. The first step is to clearly understand the problem. Managers must ask, what is wrong? What decision needs to be made? Example, a bus company wants to reduce fuel costs while covering all routes. 2. Defining the objectives. Next, the goal of the study should be clear, whether it is to maximize profit, minimize cost, reduce waiting time, or improve efficiency. Example, the bus company's objective is to minimize fuel costs without reducing service quality. 3. Data collection. Good decisions need good data. This includes both quantitative data, numbers, costs, time, demand, and qualitative data, opinions, customer satisfaction. Example, data on fuel consumption, passenger demand, and route distance is collected. 4. Constructing the model. Here, the real-world problem is converted into a mathematical model. It may be a linear programming model, simulation, or probability model. Example, the bus company creates a model showing routes, costs, and number of buses required. 5. Deriving solutions. Using OR techniques, the best solution, also called optimal solution, is obtained. This may involve equations, computer programs, or graphs. Example, the model suggests an optimal schedule that saves 20% fuel. 6. Testing the model. Before applying in real life, the solution is tested with sample data. This helps to check if the model works properly. Example, the new bus schedule is tested for 1 week to see if passengers are satisfied. 7. Implementation and monitoring. Finally, the solution is applied in practice. Continuous monitoring is done to improve results. Example, the company implements the new schedule and keeps checking costs and passenger feedback. Conclusion. The OR model development process is a cycle of problem data model solution testing implementation. By following these steps, managers can make smart, scientific, and cost-effective decisions. Next important long question is: 4. What are the opportunities of using an OR model in decision-making? Opportunities of using an OR model in decision-making. Operations research, OR, is like a scientific tool for managers. It gives them a chance to make smarter, faster, and more accurate decisions. Using OR models opens up many opportunities in business and other fields. 1. Better resource utilization. Resources like money, manpower, time, and machines are always limited. OR helps in using them in the best possible way. Example, an airline can use OR to schedule flights and staff so that no plane or crew is wasted. 2. Cost reduction and profit maximization. OR models help managers reduce unnecessary costs and increase profits by finding the most efficient method. Example, a factory can use linear programming to decide how much of each product to manufacture to maximize profit. 3. Improved planning and scheduling. Planning large projects or scheduling daily operations becomes easy with OR. It reduces confusion and delays. Example, a construction company can use OR, PERT CPM, to plan the order of activities for a building project. 4. Quick decision making. Managers often face complex situations. OR provides mathematical models and simulations to quickly test different options and choose the best one. Example, a bank can use OR models to reduce waiting time for customers in queues. 5. Better risk management. Business always involves risks. OR models use probability and simulations to predict outcomes and prepare backup plans. Example, a stock trader can use OR to analyze risks before investing money. 6. Enhancing customer satisfaction. By improving efficiency, reducing delays, and offering the right services, or indirectly increases customer happiness. Example, online delivery companies like Swiggy or Zomato use OR models to assign delivery boys in the fastest way. Conclusion. The opportunities of OR in decision-making are huge, from saving money and time to reducing risks and improving customer satisfaction. It gives managers the power of scientific decision-making instead of relying only on guesswork. This makes OR a valuable tool in today's competitive world. Next important long question is: 5. Critically examine the shortcomings of using an OR model. Shortcomings of using an OR model. Operations research, OR, is a powerful tool for decision-making, but it is not perfect. Like every scientific method, it also has some limitations. Managers must be aware of these shortcomings while using OR models. 1. Dependence on mathematical models. OR depends heavily on mathematical and statistical models. If the model does not represent the real situation correctly, the results may be misleading. Example, a model may assume machines never break down, but in reality, breakdowns do happen. This makes the solution less practical. 2. Requires accurate data. The success of OR depends on the quality of data. Wrong, incomplete, or outdated data leads to wrong decisions. Example, if a transport company uses last year's fuel prices in the model, the cost calculation will not be accurate. 3. Complexity of models. OR models can be very complex and difficult for non-technical managers to understand. This may create a gap between analysts and decision-makers. Example, a manager may not fully understand a linear programming solution and may hesitate to apply it. 4. High cost and time-consuming. Building OR models requires computers, software, and experts, which can be costly for small organizations. It also takes time to collect data and run the analysis. Example, a small retail shop cannot afford to spend lakhs of rupees on OR-based software for inventory control. 5. Assumptions limit practical use. Most OR models are based on assumptions like perfect competition or constant demand, which may not be realistic. Example, a model may assume demand for products will remain steady, but in reality, customer preferences may change suddenly. 6. Resistance from managers and staff. Sometimes managers rely more on experience and intuition. They may resist OR results if they feel it reduces their authority. Example, a production manager may not accept an OR solution if it conflicts with his practical experience. Conclusion. While OR models are scientific and logical, they are not a magic solution. Their shortcomings like dependency on data, high cost, and unrealistic assumptions must be considered. The best way is to use OR as a supporting tool, combined with human judgment and experience.